Hi, kids. It is time to have our crash review on graphing exponential and log functions, right? We did a big exponential and log properties and exponential and log equations, and now we're on to the graphs. So if you remember from last year, the objective that we are trying to highlight is the critical features of your parent or your base exponential log or graph and what happens to those critical features. So for exponential functions, right, the things we wanted you to focus on were the y-intercept, the fact that when you plugged in 1 for the independent variable, you always got the base back, and that you had a horizontal asymptote at y equals 0 because you couldn't turn any base right, into 0 by raising it to any power, right, with a domain of all real numbers. And then for logs, we said we just have the reverse, right, because logs and exponential functions are inverse operations of one another. So logs had the critical point of an x-intercept of the base. You plug in a number for x that is the base, and you get 1 back, is the exponent that turns any base into itself as 1. And then instead of a horizontal asymptote, you have a vertical asymptote. So those critical features, we wanted to know where they went when what my base was and when I manipulated my base. So for 3 to the x, what are my points? My points are 0, 1 for any exponential function, 1, 3, and the horizontal asymptote at 0. And then you slide to the y-intercept and swoosh up, right? And that describes the behavior, right? If you put in negative numbers for x, 3 to the negative 2 is 1/9. 3 to the negative 2 is, 3 to the negative 3 is 1 over 27. 3 to the negative 4 is 1 over 3 to the 4th, right? Those numbers get smaller and smaller and smaller, approaching 0. But as soon as you end up putting positive numbers in for x, 3 squared is 9, 3 cubed is 27, 3 to the 4th, right? You swoosh up very, very high. Logs are the opposite behavior, right? You have, instead of a y-intercept, you have an x-intercept at 1, 0. When you put in 3, the exponent that turns 3 into itself is 1. You have a vertical asymptote at 0. And you do slide swoosh, but you do the opposite. You slide, instead of slowly to the y-intercept and then swoosh, you slide quickly to the x-intercept and swoosh slowly. Notice both functions are increasing, but this one is concave down, no soup for you, and this one is concave up. So speaking of characteristics, I could, and so will you, Brooke, ask you about some characteristics, right? So here we are going to describe how to transform the graph. Right? Describe in words how to transform the graph, and then graph and label. So I do not have to tell you what to graph and label on an assessment. I am modeling it for you during our content videos. So when you raise your hand and say, what do I need to label? I'm going to say, reflect on what we did in the content videos, right? I'm going to model for you what to do on an assessment with these directions. Now, in truth, I won't ask you to graph the base one on a test. Well, let me take that back. We may at the beginning, and we did in your assessment. If you reflect back on your assessment in AAF, you graph the original and then graph the transformation. So remember this, but on an IB assessment, you're just going to be given this, right? You're just going to be given the transformed one and say, how did you go from F to G? All right, so e to the x, you know, is a base. E is a number a little bit, right, smaller than 3, but that is a slide swoosh situation still. So that is 0, 1, 1, 2.7-ish, horizontal asymptote, slide slowly to the y-intercept, swoosh quickly. Now, what has happened to the graph? Domain first. C is not 2, right? You remember our horizontal transformations? Horizontal transformations means that this was really x over 1/2. C is actually 2. So each one of these points (0, 1) and 1, 2, and y equals 0. Critical points, critical features. Where did they go? So every x, right, was multiplied by 1/2. And that would happen to x, right? I'm sorry, c was 1/2, you silly. Oh, there's no x here, so I don't have to do anything to the x here. But what happened to y? Two things happening to y, and this was something that messed kids up on the last unit test. Once you have done the function, e to the, I've dealt with the domain, everything else happens to the range. You are subtracting 1 and multiplying by 3. Who do you do first? You multiply by 3, subtract 1. Multiply by 3, subtract 1 to every y. Multiply by 3, subtract 1. So graph these points. Where am I? 0 times 1/2 is still 0. 1 times 3 is 3. 3 minus 1 is 2. 1 times 1/2 is 1/2. Oops, that's not a 2, that's an E, sorry. E times 3 is 3 times E. 3 times E minus 1 is 3E minus 1. 0 times 3 is 0. 0 minus 1 is -1. So I'm going to draw my horizontal asymptote. I'm going to plot the point 0, 2. I'm sorry, not 0, 2. I'm going to plot the point, I'm sorry, yes, 0, 2. Can't read my own writing. And I'm going to plot the point 1/2, 3e minus 1. Let's see, e is 2.7-ish. 3 times 9 is minus, so somewhere around here. And then I'm still going to model the same behavior, right? One, 2, 3, 4, 5. I didn't go high enough. 6, 7, somewhere around there. Sorry. Trust me, I'm not going to be pressed upon that. Slide. I care that you call it 3e minus 1. I don't really care exactly where you place it. Just be reasonable. Slide swoosh. Okay. Let's do the same thing for logs. What are my base points, right? This is a base of e, the natural log base of e. So I'm going to take the point not 0, 1, but 1, 0. I'm going to take the point Not 1 comma e, but e comma 1, and not the horizontal asymptote at y equals 0, but the vertical asymptote at x equals 0. And I'm going to say what happened to everything, right? So inside the argument, this is the argument, I'm inside log. Before I apply the function, I negate every x. That's an x, right? Then what do I do to the y's? Add 3. That's after the function, so that's to the range. Oh, there's no y here. So what do I have? I have the point -1, 3, negative e, 4, and still x equals 0. 0 times -1 is 0. Multiplying my domain by a negative, you should expect what to happen? Yeah. Flip across the y, right? Negative 2.7-ish, 4. Can't count, can I? 1, 2.7-ish, and 4. Oh, I didn't graph the original. Again, you don't have to graph the original unless I ask. And I did just ask you to, in this question, to just graph and label G. Right now, the words, what happened? Right? Describe. So I graphed and labeled critical features, critical points. What did I not do? I didn't describe. I didn't do the words. So what did I do? Right? I had a horizontal stretch or shrink. C is less than 1 by a factor of a half. Vertical, what? Stretch by a factor of 3. Shift down 1 unit. Okay, what happened over here? What happened over here? You could say right? You can't say a vertical stretch or shrink, right? Because that's a 1, right? But what happened? Right? My dilation factor was just a 1, but I negated it. So I negated the domain before I logged. It's a reflection across the y-axis. And then what? Shift up 3 units. So make sure you answer the question. Describing means give me some words. You don't have to give me formal sentences with capitalization and all that kind of stuff. I didn't ask in this one to put it in order of operations, but I would get in that habit of always doing that. I will be more specific with you on an assessment as to, do I want you to graph them both, or do I just want you to graph G? Right, so I would write this, if I only wanted you to graph the transformed function, I'd say how to transform the graph of F into the graph of G, and then graph and label G. Okay. If I wanted you to graph them both, I would say then graph and label both on the same set of axes. All right, let's go on. Let's try some more. Oh, wait, I forgot. I started to talk about this in the last slide. I want to say, what if I asked you, and this I have to ask, right? I do have to ask you if I want any characteristics. So what about the domain and range, continuity, boundedness, increasing, decreasing, max, min, asymptotes, and behavior? All right, let's pick this apart. So any exponential function, I don't care which one I had here, right? I don't care which one we have here. The domain is all real numbers. But our range, which normally is y is greater than or equal to 0, do you remember what happened? We had a horizontal asymptote at y equals -1. Continuous, yes. Boundedness, what is this? How is this function bounded? This exponential function is increasing on its domain and never decreasing. There is no max and no min. Remember, don't tell me infinity here. Max and min, by definition, have to be a value. If there is no value, you write undefined or none or does not exist or whatever you want. But you cannot tell me infinity. You have to either tell me a number or that a number doesn't exist. So that's the purpose of boundedness. This function is bounded below, but there is no absolute or even local minimums. There is obviously no absolute max. Asymptotes, yep. And behavior, you got to limit me with this. Limit notation, right? The limit as x approaches -infinity is 0. The limit as x approaches positive infinity, of g of x, sorry. Remember, the formal definition of a horizontal asymptote just says one of the ends has to go off to a number, right? Rational functions, if you level off to one function on the left, you do the same on the right, but this is exponential functions. Okay, let's do our log one. Remember, our log one looked like this because we had reflected it across the axes. So it looked like that. The domain of normal log is x is greater than 0, but what did we do to x? Right? So the domain is x is less than 0, and the range is all real numbers. Continuous, yes, right? Remember, continuity is asking if your domain is broken. My domain is not broken. Here's my domain, and it is not broken. It is smooth. This function is smooth and continuous once the domain starts. Is it bounded? Look at your range. Is it bounded? Nope. Play the nope card. Increasing or decreasing? Your domain starts at -infinity. What's your range doing? Decreasing over its domain. No maxes or mins. Asymptotes, yep, that's why I labeled it. And behavior, the limit as x goes to -infinity of g of x is what? Go to -infinity, this graph is going to positive infinity. The limit as x goes to positive infinity, there ain't no graph there, so I can't investigate I can't plug in 1 million. I'm not allowed. My domain says x has to be less than 0, so there can't be any end behavior on the far right. All right, now we can go on to the next one and try another example. So maybe pause the video and try this. And see if you get the same answers I do. Domain first. Multiply by -1. So I expect a reflection. Range next. Zero times 2 is still 0, so my horizontal asymptote doesn't change. Notice the directions just say graph and label. It doesn't say what to label, but I'm modeling it for you now. So when you get an assessment back and I've got some points off because of your labeling and you go, but I did label something, I'm going to say, did you label it the way I modeled it for you in our videos? And I don't model it for you because it's just my way and I like it the best way. It's because I know what test you're going to take. So what is 1 times -1 is -1. And 3 times 2 is 6. Count 1, 2, 3, 4, 5, 6. Label. 0 minus 1 is -1. I'm sorry, that's times. 0 times -1 is 0. 1 times 2 is 2. This time you swoosh down to the y-intercept and then slide. Wait, I thought that only happened when my base was between 0 and 1. That's what I learned last year. Oh, snap. Isn't this the same thing? Gasp. Right? Remember I taught you last year that when your base is between 0 and 1, you don't slide swoosh, you swoosh down and slide? Well, look, this is just a rewrite now, isn't it? What if I had given you this? What would you label? Right? You wouldn't start with these original points. You'd start with 0, 1, and you'd start with 1 comma 1/3. And then you would multiply and y equals 0. And then you'd multiply everybody by 2. All the y's by 2. What would you get? Y, 0 times 2 is still 0. But you'd get the point 1 comma what? 2/3. Well, guess what? 1 comma 2/3 is on this graph. What would you get here? 1 times 2 is 2. Same y-intercept. If you put 2 times 3 to the negative x and 2 times 1/3 to the x in your calculator and graph them, you will get the exact same graph. That's the power of a legal rewrite. So, what is your lesson? When you look at exponential and log graphs, maybe you should do a rewrite first and make it a little easier on yourself. I mean, I don't know. I don't know that whether the blue, thinking about the blue or the yellow was necessarily harder or easier, but it is a tool in your tool bag. If you want to legally rewrite, you can. I didn't tell you, right? But what you had to do, right? I just asked you to graph and label. Now, if you are going to rewrite, though, make sure you tell me, right? Give me the rewrite. and then how you moved, right? Notice this time I didn't say describe, so I don't have to write any words, but I expect the critical features and points. I need to see obviously where they went, okay? All right, let's do the next one. So, what do I know about my base, my parent graph? My parent graph has the point 1, 0, has the point base, 1, has the vertical asymptote x equals 0. So what has happened with this? Not too much, right? Hey, be careful. Be careful. What is my C? I'm operating on the domain. C is not 36. C is, right? This was actually, I'm not doing any, this was actually x divided by 1 over 36. My C is 1 over 36. That's on the domain. Right? I'm multiplying. So what do I get? Oh, that's kind of nice. What is that? Let's say I make this 1, 2, 3, 4, 5, 6. Let's say I make that my 1. Is to make my graph a little easier. Aren't I clever? So 1/36, right, is way over here. And 1/6 is here. And then I still slide quickly, swoosh slowly. But hey, could you have done a rewrite of this? Think about that for a second, right? Think about your log property skills. Couldn't I rewrite P of X this way? Right? And what is the log of a product? What's this? The exponent that turns 6 into 6 squared. Oh my Lanta. How do you graph that one? This is just your basic log X. Right? This just takes my point 1, 0. Whoops, I forgot my 6. 6, 1. And yes, my vertical asymptote x equals 0, and nothing happens except I'm adding 2. Well, guess what points are also on this graph? And then way out here, 6, 3. OMG. Whoops, turn that frown upside down. OMG, who would have thought a rewrite would be so handy, right? So now that you have tricks and you've got log properties and exponential properties in your bag o' tricks, pull them out sometimes, even though there was nothing in this question that asked me to, right? Now, if I have a calculator in my hands or a computer that I can access, who gives a crap? I can do whatever, right? I can plug any of these in. But when I have a calculator taken out of my hands, which IB and AP must think is important going forward, or they wouldn't make 50% of their tests without a calculator, you need to be able to choose wisely and effectively and use all your prerequisite skills to problem solve, right? And look at a problem and say, you know what? I think I want to do a rewrite on that before I graph and label it. All right, how about this? So now that I've given you that hint, what do you think you can do with this? So now I think to myself, I gave you the hint of rewriting before, but now every time I think about these graphs, I'm going to consider whether I should rewrite it. Now, this isn't devastating, right? But what is firstly, it is a horizontal, and it's a horizontal what? C is 9. C is 9, that's a horizontal stretch, right? Because C is bigger than 1. But you could do a rewrite on this. A log of a quotient is what? Right? It's that 3 and that 9 that kind of gave me the clue, right? Because what is the exponent that turns 3 into 9? This is just a simple shift down of 2, right? So my basic log graph with x is equal to 0, the point 1, 0 has been shifted down 2, and the point 1, 3 has been shifted down 2. Whoops, sorry. Yeah, there we go. 3, 1, excuse me, 1, 2, 3, 1 has been shifted down 2. Done. So I might not think about it with this, because remember, I could have easily just left this one alone and said, what happened to the point 1, 0, 3, 1, and x equals 0, multiplied by 9. Right? Obviously not by my scale, but trust me, that point is on there. So is 27, 1 on there. And then my horizontal, vertical asymptote doesn't change because 0 times 9 is still 0. Right? I could have done that just fine. But look at this one. What is this? Props to the rescue. Right? This is log base 2 of, oh no, I'm not going to write that 3 up there. Where am I going to write that 3? Oh yeah, bring it on down. And what is the exponent that turns 2 into 1? Hello, 0. So I am graphing a basic log function that is multiplied by -3 and is shifted right 4. So what happens to my points? 1, 0. Oh, I lost my base. 2, 1, and x equals 0. What happened to them? Moved right 4 to the domain, to every x, and then every y got multiplied by -3. No y's there. So what do I end up with? One plus 4 is 5. 5, comma 0. Right? Because 0 times 3. But what's this point? This new point is 2 plus 4. 1 times -3. And how about my vertical asymptote? Ah! My log graph has been negatized. So I am still going to slide quickly along the vertical asymptote, but from above to the y-axis, and then swoosh slowly. Cool? Oh, those properties. I heart properties of logs. Last ones. Fairly simple, right? Exponential function. I am operating on the domain, but not with a multiplier. So I have my exponential function 0, 1. 1 comma base. What's happened? I've operated on the domain, going right 3. And of course, I still have my horizontal asymptote at y equals 0, and I didn't do anything to y, so it's still there. I didn't multiply, so I'm going to slide slowly along here to what used to be the y-intercept, and then swoosh quickly. Right? That is a critical point when you start to swoosh quickly, right? In exponential growth. It's kind of important. So what did I change here? All I changed here was I put an absolute value around t. So if I actually gave you this function, it might be worth your time to just graph this one first and then think to yourself, what's going to happen to every negative x that I put in? Every negative x or t that I put in got turned positive. And then what were my positive x's? I just took the positive piece of this function and reflected it across the y-axis. I mean, you don't have to. You can still think about, well, what should I do? Make a table or whatever, because it's not as simple, right? Absolute value is a fake function. It's not like I can say, multiply by this or move right and left or whatever. No, you have to think about what absolute value is doing. So it might be worth your time to think about what happens without absolute value, and then figure out what your negative domain pieces looked like, get rid of them, and just reflect the positive domain across the y-axis. Okay. All right. That's it for this video. We didn't leave any examples to do in our live session of this because our next objective are application problems. So we wanted to spend a lot of our live sessions doing the application problems because this was all really Except for the addition of the rewriting with properties, this was all objectives from last year. All right, I will see you in our live session.